that you will be facing me for many, many days, each day in the bitterness of late afternoon. So we have to find some way to wake up and pursue research. I'll try to select some different music every day. That was a song from Brazil. So maybe I can do something different in every language every day. So I'm very happy, and there are some reasons I'm very happy. Number one, I'll only give you two reasons. Number one, somebody handed me this wonderful packet of abstracts of presentations that are going to be made in the afternoons after my talks. And they have wonderful titles, like Iconicity in Chinese Sign Language, and Semantic Field Again, Synonymous Homogeneous Construction and English Vocabulary Acquisition, Cognitive Development, Metaphorical Mapping and Expansion of Lexicosemantic Categories, the Role of Frame Shifting in Humor from Social Perspectives, Embodied Realism in Cognitive Linguistics. This is terrific. It's tomorrow's research today. So, of course, I'd like you to go post all of these on the Cognitive Science Network. Just sign up at ssrn.com, become a user, post your research, and then there it is. The whole world will be able to see it. In fact, during lunch, the next installment of these little email messages that we send out every week just appeared. So for this week, we're announcing How Compression Gives Rise to Metaphor and Metonymy by Gilles Fauconnier. When Do Understanders Mentally Simulate Locations by Nian Liu and Benjamin Bergen, and other sorts of research. We announce some of this every week. And some of the use of the Cognitive Science Network, for example, you heard Professor Herartz talk about the role of polysemy in cognitive sociolinguistics. Gilles Fauconnier and I have an article on polysemy and conceptual blending, on the way in which the basic mental operation of conceptual integration makes polysemy possible, and 4 different ways, 4 varieties and kinds of polysemy that come up under conceptual integration networks. That's available on the site, like many other articles. So no waiting, no fuss, no muss. Now, the second reason that I am very, very happy is that I went to Sculpting in Time Cafe over next to Deep Tennis after lunch, and I asked for a latte, a cafe latte. And this is what they served me. This is a beautiful cafe latte that I had over in the cafe. And notice that they call this latte art, where you take coffee and you put milk in it, but you drizzle the milk in such a way as to paint the surface of the coffee. I just drank this. But before I drank it, I took a picture of it to show you, because this is the kind of inventiveness that comes from the basic mental operations of creativity that human beings have, to take the surface of a coffee and to turn it into a canvas for art. It's very inventive. Cognitive linguistics, you recall, is a branch of cognitive science in which language is principally seen as a branch of human cognition. And as these lectures go on, we will pick up the pace and move faster and bring more and more technical features and aspects of language into analysis. But it's important here at the beginning to remember that these analyses are, for the most part, not specific to language. These mental operations are, for the most part, not restricted to language. They are basic mental operations that make many higher order cognitive performances possible. And so we need to focus on the way in which these mental operations work generally, so that we can see how they work in language. There are many ways in which conceptual integration networks make language possible and make the production of language possible and make the change of language possible, and we'll be going through some of those. So let us pick up where we were, talking about conceptual integration. Remember, you saw that you can find some of it in this book. You don't know how many of you were here this morning. I think most of you were. I recognize faces. But you recall we talked about the man who is at a wedding party, engaged in the wedding party, but while he's at the wedding party, he is remembering the fact that 3 weeks ago he was diving with his girlfriend off Cabo San Lucas. And it is a major scientific question in cognitive science why evolution has not stopped us from developing the ability to think of two things simultaneously when they're incompatible and where one of them is not serving present action and in fact goes against present action. Is there not a danger that we would get confused? Is there not a danger that we would make mistakes in action? Why do we have this ability? And I mentioned Glenberg's analysis of this problem and a Terry Deacon's project to try to work on how it is that the inhibition of thinking about what is not relevant might have gotten lifted evolutionarily. The disinhibition of activating rival concepts. The brain is all about activation, as we saw in that quotation from Sherrington about the brain as an enchanted loom. I very often show a picture of a brain, and I'll show you one tomorrow and the next day. And it's easy in looking at that brain to think, there's the brain, and that is thought. But no, that brain is dead. That brain is not good for thought at all. What matters is what's active in the brain. And activation varies. We tend to think of our concepts and our abilities as things that are always there and that are always ready, but not so. What your brain can do depends upon what is active. And it's a real question why you should have the kind of brain that can activate things multiply and simultaneously. And I will talk about that as we go along. The hypothesis is that perhaps human memory and conceptual integration evolved simultaneously so that memory would supply better material to conceptual integration so that we would be more inventive. So anyway, there's the man at the wedding party. He's thinking about diving with his girlfriend off Cabo San Lucas, but she's not here at the wedding party. He makes a connection between the bride and his girlfriend. He projects selectively. Notice the girlfriend is not here at the wedding, but she is projected into the blend. And he is now mentally running a simulation. It is a blended simulation. It has emergent structure, selective projection, running the blend, and emergent structure. Now, in the blend, he is marrying his girlfriend and contemplating the prospect. Notice that that event is not in either of the input spaces. In neither of the input spaces is he marrying his girlfriend. But now there is emergent structure in the blend. In the blend, he's contemplating marrying his girlfriend, in fact, right here. Conceptual integration is an operation. It is not a diagram. There are no circles and arrows in the brain. And certainly, conceptual integration does not look like this fetish four-space diagram that I am putting up here. This is just something I can point to. Conceptual integration always has a network. of mental spaces that need to be connected in order to be creative. There are always input spaces, vital relation connections between them. Cannot start blending without some kind of connection between some kind of conceptual link. We call them vital relations for the most part, between input spaces. More can develop. Indeed, that's one of the virtues of conceptual integration. Projection to the blend that is selective, not cut and paste, and the emergence of structure in the blend that is not contained in either of the input spaces, like the wedding to the girlfriend, right? The purpose of a conceptual integration network is not to create a blend that eliminates the network. On the contrary, often the purpose of the blend is to make it possible for us to command a network, to grasp and hold on to a network that otherwise would be too large and strange and alien for us to understand with our human brains. But the blend gives us a human scale platform, a place to stand, something we can grasp that is congenial to human cognition, and from which we can organize a conceptual network that might otherwise be beyond our mental abilities, as it seems to be beyond the mental abilities of almost every other species. Now, I gave you the riddle of the Buddhist monk, and I asked you to solve the riddle. Buddhist monk begins at dawn one day, walking up a mountain, reaches the top at sunset, meditates at the top overnight until at dawn he begins to walk back to the foot of the mountain, which he reaches at sunset. Make no assumptions about his starting or stopping or about his pace during the trips. Riddle, is there a place, you may not know where it is there a place on the path which the monk occupies at the same hour of the day on the two separate journeys? Yeah, so here was our monk, dawn, he rises, he walks up to the top, sits down at evening, meditates overnight, rises at dawn, and walks back down and reaches the bottom at sunset. What's the answer to the riddle? Who has an answer? Who has an answer? Is it true? Is there a place that the monk occupies on the same hour of the day on the two successive days? Now, you should not feel embarrassed. I must tell you that I have given this riddle to many physicists and mathematicians. And the first thing all the mathematicians say is, that's the fixed point theorem. It isn't. But this can be a hard problem. There's an answer in the back, yes?
Assuming that it would be the distance, okay.
No assuming.
Hold on, okay.
He can move any way he wants.
Hold on. Okay, so if the guy's going up the hill, would be at the same point that he would meet himself if he could come down.
Exactly. Now notice what he just did. He said that he would meet himself. Now, notice it is impossible for a person to meet himself. This does not happen. Next, notice that the word meet is ungrammatical for this scene. There is no meeting. The reflexive himself has no referent for this scene. The linguistics, the place is where he would meet himself, is ungrammatical for this scene. You cannot use this language grammatically of this scene. But that is not the scene to which you're applying it. What has just happened is someone has said, I know what I'll do. I'll take the journey on the first day and the journey on the second day, and I will blend them. I will superimpose them. It's as if you had a video camera and you videotaped the monk on day one. And then you videotaped the monk on day two video camera just like this one. And then you had two projectors, and you projected them on the same screen, right? And it's dawn. There are two monks on the screen. And they have to cross somewhere. They have to cross somewhere. Now, this scene is a blend. It happens to be one that doesn't come quickly to mind in many cases. Notice that you understood this before I showed you this scene. Once the idea of blending them had come to you. So, notice that there is selective projection to the blend. That is, we do not project to the blend the date from the input spaces, because the date in one and the date in the other are two incompatible dates. We do not project those to the blend. We do project the time, and very interestingly, as we'll talk about later, we project the topology of space-time collocation. You have to preserve that under the topology principle, as we'll discuss later, in order for this to work. Notice that there is emergent structure. Namely, there are now two monks, and they're the same monk. And there is a meeting. There was no meeting in the original scene, but now that you have blended them, there is emergent structure. There is a meeting, because you know that when two people are approaching each other on a path and they go to opposite terminals of the path, you know they have to meet. That's a common human frame you have of interaction. And you can use that blend to understand this network of the monk's movement. And you didn't quite see, many of you, that there would be a place on the path here that had identity to the place on the path here. And the time that the monk is at this place is the same time as the monk is at this place, because you were working in a big network. But once it was blended to something that you're very good at grasping, you understood it immediately. Immediately. You have never seen a person meeting himself. Now, why can you do this thing that you have never seen before? It is not because you have a genetic module for understanding monks meeting themselves. It's because you have a mental operation of blending. And this is not even a double scope blend. This is a mirror network, which I'll discuss in a minute. Now, once you see this, you realize that the selection projection is in fact really selective. What would happen? What would happen to you if you were walking along a path and suddenly you saw yourself coming at yourself? What would you do? Yeah, notice that in the blend, the monks don't even notice that they're meeting, right? Right? If you saw yourself approaching yourself, you'd probably say, ah, and run in the other direction, or what is going on, or, right? But no, the awareness of the other monk as such, and that it is the same, that the two people are the same person, does not get projected to the blend. You keep that out. Moreover, you do not derive from this various kinds of inferences. You do not say, oh, I see now, I was stupid before, but now I understand how the world works. It's possible for people to meet themselves. What is not projected to the blend, for instance, is not the monk getting confused saying, wait a minute, is this yesterday? Yesterday I was coming up the hill, and now I'm coming up the hill. I thought today was today. The monk in the blend is not getting confused about time. No, what's happening in this case is the purpose of this conceptual integration is to do what we call solving for the inputs. You want to understand something about the relationship between the inputs. And that is the purpose of the blend. It's not to create a fantasy world in which people can suddenly meet themselves. Now, once you see this, it's pretty easy. And in fact, people are quite amazed at how easy it is, and they say to themselves, how could I have missed that? So here, for example, is the Buddhist monk version 2. Now he moves at a different pace, very slowly at the beginning, and then he races up the hill and sits down, meditates overnight, rises at dawn, and goes back down with a different speed, right? But that's no problem, because he gets back down to the bottom, and if you blend them again, now with their different speeds, now last time he met above this cusp. This time he meets below this cusp, right? And you can even make kind of extreme examples here. He races up and then goes very slowly at the top because he's tired, and sits down and meditates overnight, gets up at dawn, goes down very slowly because he wants to see the view, beautiful view from the mountaintop, has to race back down in order to get back to the temple in time for dinner. Okay? And if you blend those, now he meets way up there, see? But the point is he has to meet somewhere. Because once you recognize that when you put these together, you have two people approaching each other on a path, they have to meet. Now what probably hasn't occurred to you is that you projected this in such a way that you kept well ordering. That is, if he's on a certain spot on the path at a certain time of day, you bring that connection into the blend, and you made it so that if he's at a spot at time 1 and time 2 is later, then time 1 and time 2 come into the blend with the same relationship in the blend that they had in the inputs. Now, in fact, that's not necessary for the blend. It could be, as long as you project together the two that are connected by the time-space identity, you could project them in so that the monks hop back and forth and go up and down the path like this. As long as they start at dawn and end up at dusk, and as long as you preserve that time-space collocation, it will work mathematically, but it's not so easy to see. What makes it easy to see is the meeting point. So let's review just a little what's going on here, and hold in mind this all-important fact that I can talk about the blend because I have language that suits the blend. I have language that suits the human scale scene. And when I talk about the blend, you understand what it means for the network. So if I say the place is where he meets himself, that is language that is grammatical for the blend. But notice, that is not the riddle I asked you to solve. The riddle I asked you to solve has to do with the relationship between the two inputs. I can talk. Language is now able to communicate about an entire conceptual network by using constructions we have that fit the blend. Hold on to that point. It's one of the many important ways in which conceptual integration makes language possible. Because, a phrase you'll often hear, now you do not need new language to express new things. You can express new concepts and new structure in networks with old language. You already have everything you need. I did not have to invent grammatical structure. I did not have to invent lexical items. I could say, the place is where the monk meets himself. And that is understood by you as conveying structure about a great network. So there are input spaces, and in the two input spaces, there's a path, and there's a monk, there's the ascent, and there's the descent. Right? Now notice when you, the connection between them is quite obvious because this is a mirror network. A mirror network is one in which the input spaces share the same conceptual frame, where by a frame I mean the same organizing structure: causal structure, participant structure, modal structure, necessity, probability, things like that, right? Image schemata, and so on. In both of these, there is a monk who is traveling on a mountain path from a source to a goal in the space of a day, meaning from dawn to dusk. That conceptual structure organizes both of these inputs, which makes it very easy to make vital relations between them. The path is identical to the path. The time frame, not the date, but the time frame is identical to the time frame. The mountain is identical to the mountain. And so we can connect them. There is a generic space, or there can be a generic space, in which what is shared between the inputs is captured. Now, do not think that the generic space is already there independent of the connection, or that the reason we can connect them is that there is a generic abstract space. On the contrary, people often remanufacture what goes into the generic space as they're working on the conceptual integration network. They try different vital relations between the inputs to see if they can get a good network. So these things are dynamic, and they change as we work, and you'll see many examples of that. There is projection to the blended space. Notice something interesting. The paths are fused. We project the two paths down into the blend as one path. So there's fusion here in this blending. But the monks are brought in separately. They are not fused, right? The projection is selective. There is emergent structure in the blend, namely the monk meets himself, something that does not happen in the inputs. So a typical network looks like this, but remember, please, conceptual integration is a mental operation, and we will go through a number of its features. It is not a diagram. I can show you conceptual integration networks that have 45 mental spaces, where there are blends and the blends become inputs to other blends. Conceptual integration to create conceptual integration networks is a basic mental operation which we use again and again and again in constructing meaning. It has certain features: vital relations between inputs, selective projection to the blend, emergent structure, creativity in the blend. This is the basis of human creativity that makes culture and the invention of culture possible. And culture supports our use of conceptual integration, and we all working together support it. So, selective projection and emergent structure. Now I want to give you another set of examples to try to make this survive in memory, because these are very basic ideas that will get much more sophisticated as we go along. I would like very much to run a set of experiments, blending box experiments. And it goes like this. Suppose we show somebody a scene like this. And we show them that if you press the blue button, that's what happens to the blue ball. Okay? Got that? Watch the blue button get pressed here. You'll see it turn black. Press blue button, blue ball goes. Okay? You just show them that. And when you press the red button, first there's the blue button again. Now when you press the red button, watch the red button get pressed, that's what the red ball does. Okay? Everybody got this? Press the red button, that's what the red ball does. So let's go back a second. Press the blue button, that's what the blue button does. And if you press the red button, that's what the red button does. Okay? And now you tell people, okay, if the balls land on the green oval, you get 100 yuan. 1,000,000. You tell them whatever. You give them an incentive. You show them this little computer with buttons. If the balls land in the green area, you get lots of money. Now, you could also do this with dogs. They wouldn't care about the money or the computer screen. But suppose you built a box where the dog could press one lever with one paw and one lever with the other paw. And these were very yummy treats that the dog could smell. And it's behind plexiglass. But there's a big hole where the green oval is. And if the ball falls in that hole, they get to eat the yummies. You could do it with birds, New Zealand rooks. They could stand on one and peck with the other, right? You could do it with all kinds of things. Now, I would like to know at what age young children can do this. Notice this is just a mirror network. It's like the Buddhist monk in the sense that you press the button, the ball rolls, it goes on a trajectory, it stops. Does not land on the green. All right? I'd like to know if dogs can do it. This is pretty challenging. Now notice, I have shown you two things. Press blue button, blue ball rolls. Press red button, red ball rolls. How are you going to get the balls under the green oval? What's the answer? Press them at the same time. Now, that would be cut and paste. And if you press them at the same time, and we have to be careful of that because it's very easy for children, the body is bilaterally symmetric. So it's very easy to do things at the same time on both sides of the body. So if you just flapped your hands down, that's what you'd get. No good. They don't land on the green. Notice that is a cut and paste version of the two inputs. If you take everything from one and everything from the other and you put them together, no solution. So what's the solution? Not you this time, somebody else. Come on. What do you do? I'll show you this again. Right? No good. What do you have to do? No, somebody else. Come on, be brave. Yes, first the red one, then the blue one. Now notice that's selective projection. You're going to have to not hit the two buttons at the same time. You're going to have to hit the red one so it sort of rolls down and then hit the blue one so that the blue one will come and hit it. Notice you have not seen that. Right? You're thinking it. You can come up with solutions that you have never seen. And you can do this not because there's a genetic module for pressing buttons in a blending box. Nobody's ever seen this before. Yes, what you could do is something like, not that, but watch the red one first. Yes. Now that's magic. All right? It seems like nothing. And the reason it seems like nothing is human beings are blenders. This is what you do. You can put things together selectively, imagine a simulation, not bring in certain kinds of things. Notice the trajectories of the balls are not brought in. The timing is adjusted. It's projected in a certain way. And you get emergent structure. Namely, the balls bump into each other, and it lands on the screen, and you get 1,000,000 yuan. Or if you're a dog, you get the yummy treat. Or if you're a bird, you get whatever you like. Right? This is actually extremely inventive, extremely creative, but it's what we can do all the time. And I'll show you more. Notice again that there's selective projection and emergent structure. Now remember this morning I said that human beings are not like other species. They can conceive of things that run way beyond human scale, beyond local time, beyond local space, beyond just the few agents that you see right here in the situation in which you're interacting. So I'll give you an example. Again, so far we're just working with mirror networks. We have not gotten up to a double scope network in these little examples. So there was a man, Hikam El-Garrouche, and in 1996 he set the world record in the mile. Okay? He ran the mile the fastest. Hikam El-Garrouche. And the New York Times wanted to convey what his accomplishment consisted of. So they gave this graphic. And these people, by the way, it's of course already blending, that you can look at these little black lines and regard them as a representation of a race. Nobody's running. And I can say, these people, and you're not bothered, because in the blend they're people. You're not deluded, but in the blend they're people. We'll get to that. Just for now, these people are the fastest milers from each of the preceding 6 decades, except for Roger Bannister and Herb Elliott. They're both from the 1950s, and they had to put Roger Bannister in because he was the first person, I think, who broke the 4-minute mile or something. He's just very, very famous. So here's Hikam El-Garrouche from 1996, Stephen Cram from 1985, Sebastian Coe from 1979. And what they have done is placed these little symbols of the runners on the track where they would have been if they had run against Hikam El-Garrouche. Of course, this takes some computation. I've worked it out. They took the time of the runner for the mile and assumed that the runner was running at a constant speed. And that's how they figured out where to place them. Of course, milers don't do that. So this is quite inaccurate in that way. Now you understand, because of this blend, the accomplishment of Hikam El-Garrouche and how fast he is. It is a mythic race. Notice you're not deluded. You don't think that Roger Bannister ran against Hikam El-Garrouche, right? They're 40 years apart, 45 years apart, right? Now I can say, now I have language for this blend. I can say, oh, Hikam El-Garrouche was really wonderful. He defeated Roger Bannister by 120 yards. Now, that language is grammatical for the blend. It is not true of the inputs. Hikam El-Garrouche and Roger Bannister never competed against each other. Where is this 120 yards? It's only in the blend. Moreover, Hikam El-Garrouche never defeated Roger Bannister. He never defeated any of these people in the inputs. But in the blend, he defeats them. Okay, so let's look a little bit at this selective projection. It's a mirror network. And mirror networks come up all the time. It's a mirror network because each of the input spaces, and there are 6 of them, have the same frame. It's a race in the mile. And one person is taken from each of those inputs. Now notice, in each of those inputs, the person is not just the winner. The person is the world record holder when they cross the line. Each of these is a world record in the mile. But now, Hikam El-Garrouche gets projected down into the winner in this frame. And luckily, there are these other roles for projecting these people. And they come into the blend as losers. Up here, they're winners and world record holders. Down in the blend, they're losers. That is emergent structure. All of this is emergent structure, and we have language for referring to the blend that lets you understand the cross-time, complicated network, the relationship across all of these people. And so with this language and with this human scale blended frame, we can say things like, Hikam el-Garouche beat Roger Bannister. And Hikam el-Garouche defeated Roger Bannister by 120 yards. This language comes right up for the blend. It's completely false for the inputs, and it's the inputs you want to understand. But now you have language, not just a conceptual network that can be understood by grasping it through the blend. It's a mythic race. You also have language that lets you understand the network without having to invent new constructions, new grammatical structure. All right? Now, this is a kind of fictive interaction. Fictivity is very important in human conception. It's, in a way, a shame that we use this word fictive, because we think of the fictive as opposed to the true. That should almost be retired. Fictive conceptions are really important for people in understanding the truth. They may be fictive in part of the network, but they help you grasp the truth that runs across the network. These people on this track never actually interacted with each other, but you are built to understand human interaction. That's what you're built for, to understand human interaction with a few agents. Construct a blend that has fictive interaction, and you can understand it. And that lets you understand the network. There are many different kinds of fictive interaction. In fact, by the way, this is a bunch of references to work by Ana Margarita Abrantes and Esther Pascual, who've worked on fictive interaction in legal discourse and trials, in theatricality in everyday life, and so on. We very frequently understand what's going on in the outer space network by a kind of fictive interaction, or by fictivity in general. So the Buddhist monk, interestingly, is fictive interaction, right? In the blend, there's an interaction between two people. There was no interaction in the input spaces. But that interaction gives us a human scale frame. Now here is another fictive interaction. The philosopher says, it's a modern philosopher who's teaching a class. And he says, I claim that reason is a self-developing capacity. Kant disagrees with me on this point. He says it's innate. But I answer that that's begging the question, to which he counters, in Critique of Pure Reason, that only innate ideas have power. But I say to that, what about neuronal group selection? And he gives no answer. Now, I'm pushing it a little at the end there because, of course, Kant did not know about neuronal group selection, right? The important thing is there's no Kant in the classroom when the modern philosopher is talking. Kant is dead. He's not there. Now, one of the problems I have in talking about conceptual integration is I need people to see what's going on. So I give spectacular pyrotechnic examples like the Buddhist monk and the mythic race. And it is misleading because when you look at those, it's easy to think, oh, I see, conceptual integration is a goofy thing that happens on Saturday morning cartoons and in wild stories. No, these are just the ones you can see. Notice that this way of talking about disagreeing with a philosopher, this is just the normal way to talk about it. As far as I can tell, when philosophers talk about the way they study and what they think in relation to how previous thinkers have worked on the problem, the basic language that they use is this. This does not look exotic or bizarre to us at all. We say Kant disagrees with me. Now, of course, Kant was dead before the philosopher was born. Kant cannot disagree with this man. And you know that. But in the blend, there's Kant and the modern philosopher, and they're having a debate. In fact, Mortimer Adler wrote an introduction to the great books in which he called it the Great Conversation. Right? This is our standard way of understanding the sequential analysis of problems. We're not deluded, but there is a fictive interaction in the blend And this means suddenly we have language to refer to the blend and let us understand the whole network. So we can say things like, disagree with me. That's grammatical for the blend. He says it's innate, but I answer. Now, where does answer come from? Right? The modern philosopher cannot, in the input spaces, answer Kant, but in the blend he can, and you know what that means. You can project it back to the network, to which he counters. Well, Kant cannot counter something that the modern philosopher says in the input spaces, but in the blend he does, and you have this language. But I say to that, you know, blah, blah, and he gives no answer. So all of the language of two people having a debate or a disagreement with each other, indeed all of the conception, comes right up in the blend and allows us to understand this entire network. The riddle of the Buddhist monk looks like this. There's a modern philosopher, there's Kant. The works of Kant are in the space with the modern philosopher, but Kant himself is, of course, not. The modern philosopher has knowledge that Kant existed, but Kant does not have knowledge that the modern philosopher existed. There's a debate frame that one can recruit. And you have a conceptual integration network. Now this is, and I challenge you, just go look at the newspapers. Go look at books. You'll find this all over the place as soon as you leave this hall. So, for example, in France, there is an electronic summary of the news that's published in the newspapers. And you know the newspapers have opinion columns, right? Now, these opinion columns are written by journalists overnight and published in the paper in the morning. And typically, none of them knows what the other one is going to say. They wrote them without having a debate. But the summary, in order to summarize the columns written on a particular point, political point, governmental point, uses just this conceptual integration network. So, one person will assert and contradict. One person will say to the other, no, you're wrong, right? This is how the summary goes. This is in French. But if you look at the language, what you'll see, translation into English here, they're addressing each other. One asserts, you know, columnist A asserts, we should never negotiate with terrorists. And columnist B says, on the contrary, you're wrong. That's exactly what we should do. So not just the summary language, but in fact all of the discourse markers, on the contrary, come up, available for the blend, so that we can understand this network. Now, this is extremely common, and you find it in places even where there are not any people, right? The bean burrito is California's answer to France's croque-monsieur, right? So it's as if you have these fictive interaction between different people eating different foods. And you've got your croque-monsieur, which is a sandwich, but I have my bean burrito. Or Stag's Leap Chardonnay, that's a wine from a vineyard, Stag's Leap, is California's answer to Corton Charlemagne, right? Fictive interaction, fictive debate, fictive theatricality even, is a standard way of understanding a mirror network involving agents that disagree or that have disanalogies between them. Again, what's happening is that you have input spaces, vital relations, and we'll discuss what some of those are soon, vital relations between the input spaces. A generic space is possible, a perhaps dynamically shifting generic space, which captures whatever the vital relation connections between the inputs at any given time. Selective projection to the blend, emergent structure, and a cohesive structure in the blend. Now, emergent structure is creativity. The fact that it's anchored in inputs you know gives it intelligibility. This is a way to get something more out of nothing but, to start with things at one level and of one kind, and to generate mentally things at another level and of another kind. So now let's look at a double scope network. And so in summary, what we will have looked at is basic mental operation of conceptual integration, which in its rudimentary forms we seem to share with many mammals. The way in which it connects mental spaces, projects selectively to a new conception, which is a blend, where there is emergent structure. And we'll talk about the many different purposes here. And some of the things we've seen are that this allows us, or seen, some of the things we've suggested and that we'll be exploring, is that this allows us to understand mental networks that otherwise would be beyond our grasp, that otherwise would be beyond the scale of what we're built for. This allows us to understand what we are not built to understand, except that we have this ability. And it also allows us, as we'll explore, to take a relatively small, grammatical structure is very complicated, but it's nothing compared to conceptual structure, to take a relatively small set of form-meaning pairs and to use them equipotentially to talk about anything. So now we're going to look at a double scope network. Remember I said a mirror network connects inputs that share a frame. Well, a double scope network is when the inputs have conflicting organizing frames. Organizing frames that conflict on central organizational structure, causality, participant structure, modality, things like that. So you would think that having two things that do not go together, they should never be put together, you should never confuse them, would stop you cold. And indeed, this seems to be what stops anything in this world. Whatever Harold draws is real. So he wants to go for a walk. Well, he needs light to go for a walk, so he draws a moon. And so he has light. And the moon stays with him. And he needs a road, and so, as it says, remember this is a book for 3-year-olds. He made a long, straight path so he wouldn't get lost. And he set off on his walk, taking his big purple crayon with him. Okay? So what he draws is real. Now, what's going on here? Well, let's take the moon. You know that the moon gives light, and when you walk, because it's so high, it sort of seems to stay with you. Or you don't get away from the moon. Right? You know the moon is not created by human beings. It's certainly not created by drawing. But over here you know about drawing. And it's already a blend that this thing can represent the moon. But you know about drawing. You know that you can make a sketch that does come into creation, into existence, because a human being made it, but it doesn't give light. But now, you project those two things. Well, let's stay here for a minute. You project those two things into the blend. And now you have a moon that can be drawn, but it gives light and stays with you. Now, this is something you have never, ever seen. It's brand new. Nobody taught it to you. You haven't learned it. You can't produce it because it was in your social environment. But you have no trouble putting it together. And it's not because you've got a genetic module for understanding that drawn moons give light. Because they don't. It's false. You should not have this. But here you have a world with a completely different physics. You have no trouble, and the 3-year-olds have no trouble understanding it either. So Harold goes on his big walk. He has a lot of fun. But like all 3-year-olds who've had an adventure, he gets a little nervous and wants to get home, but he can't get home. He needs some food, so he draws a tree, he eats the apple, but he doesn't want to leave all this fruit, so he draws a dragon to defend the apples, but then he gets afraid of the dragon, and so he's backing up, but his hand is shaking, and so that's water, and he falls in it. And he has to come up and draw a boat. He's a very inventive little 3-year-old. Children have no trouble understanding this. But finally, he wants to get home and go to bed. This is another blend. It's important. I call it the parent blend. All parents want their children to go to bed. And you want the child you're reading to blend himself or herself with Harold. Harold wants to go to bed. You want the child to go to bed. This is another blend, right? All these books end up with kids going to bed. It's because you want this one to go to bed. And you don't just want them to understand this one, you want them to make a blend. Okay, he wants to go home. Can't get home. Doesn't know how to get home. Now, who here is as smart as a 3-year-old? How does he get home? Yes, pretty much. He just draws his home. He remembers, but it's a nicer story than that. He remembers that through his bedroom window he could see the moon. He's got the moon, and he's got the purple crayon, so he draws his bedroom window, and ipso facto, presto changeo, he is home. Now notice that this is translocation in space by drawing. This is a physics you've never seen. It is an emergent physics. It is a creative physics. It is an innovative physics. No 3-year-old has any trouble understanding this. And moreover, they don't have any trouble continuing the story of Harold, of saying what Harold might do with his purple crayon. Now this is a double scope integration. It's a dramatic one. And again, you might be thinking, oh, I see, this is just a mental operation for goofy kids' books. On the contrary, these are the ones where I can make it clear that there is a blend going on. All these same features are going on in your head all the time. It's not cognitively costly. So what has happened here is that there is a mental operation that has created new structure. And what we need to ask about this is, what are the operations of this? What are the operations, mechanisms, principles, and constraints of this kind of creativity? Why should we have them? And what's the neurobiological substrate? Now, there is a great elaborate science to answering these questions. Some of it is embryonic. Some of it is much farther along than other parts. It's an open project. And of course, we hope many of the great advances will come from you. And over these talks, we'll be talking about certain features of this mental operation. There are some overarching goals. One is achieve human scale. When you're making a blend, try to get something that human beings are built to understand. Compress what is diffuse, obtain a global insight, strengthen vital relations, which is these connections between mental spaces, come up with a story, go from many to one. Yes? Yeah, that's an abbreviation for taking a vast range of things that's too many to be contemplated and compressing them into something that you can manage in such a way that it will give you insight into the many. And I'll be going over many examples of that. This is just preview of coming attractions. There are constitutive principles, matching, that all blending has. Matching and counterpart connections, generic spaces, blending, emergent meaning. We compose things, we complete things, we elaborate them in the blend. There's a range of vital relations that we will be going over. There are things like change, identity, time, space, cause-effect, part-whole, representation, role connectors, analogy. So for example, just to give you a taste, between the moon and the drawing of the moon, there's a representation link and an analogy link, because the drawing of the moon has a topological analogy to the shape that you see in the moon. This is extremely common, to take a representation link that also has an analogy link and to compress them into an identity in the blend. Disanalogy property, there are governing principles for compression. This is the many to one, but how you take something that's diffuse and compress it into something that you can understand without losing the network. Borrowing for compression. Now, I'm not going to go through these, because we'll be looking at these again and again and again. Many different kinds of compression, many kinds of results from compression. There are networks of compressions and conceptual blending that we find again and again and again. Here's one, here's another. You don't need to grasp these yet. We'll be looking at examples and I'll call them up. Plenty of governing principles. These are sort of optimality constraints. They can compete with each other. The topology principle. So for example, the Buddhist monk would not work if you did not give top priority to the topology principle. You have to keep the space-time relationships in the inputs identical as you project them down into the blend. If you don't do that, you don't solve the riddle. But there are others, pattern completion, web, unpacking, and each of these has a definition that we can go through and that we will over the coming days. There are different kinds of networks. Now, again, I'm doing this pedagogically and trying to lay this out. Conceptual integration is an operation that has principles. It works over all conceptual spaces. We have not found a conceptual domain in which it does not work and does not work according to the same principles. You can have a conceptual integration network that has lots and lots of spaces that cascade. Some become inactive, you recover them later and so on. So when I just show you these 4 spaces, or I tell you there are certain kinds of networks, these are just cognitive reference points. It's like 10 is a cognitive reference point for numbers, but there's an uncountable infinity of numbers on the real line. These are just highlights. These are things that come up again and again and again. Simplex networks, mirror networks, single scope networks, and double scope networks, and I'll be picking out some of those. And tomorrow, what I will begin with is a literary example of a double scope network from Racine. And here we will actually look in some detail at the language that is used in that passage and how the conceptual integration network that is put together makes it possible for the network to be commanded and understood by using expressions we already have to express new meaning that it comes up in the blend. Preview of other attractions. Later on in this set of lectures, we'll be talking about the way in which conceptual integration makes language possible by making it possible to blend form and meaning, by making it possible to take different constructions and to blend them into a construct in a way that is selective but has emergent structure. That makes it also possible to solve the central problem in the development of a language, which is how to use a relatively limited number of constructions with equipotentiality so you can talk about anything that you want to talk about. So the beginning parts of these lectures are going to be looking at the mental operations. And the second half of these lectures are going to be looking at the role of these mental operations in language. And this is what is characteristic of cognitive linguistics. To reiterate, language is a branch of cognition. And if we want to understand language, we need to look at the way in which human higher order cognition makes it possible for language to come into existence and to operate. This is not to say that any one of these abilities, art, music, dance, social cognition, might not develop some structure that's more particular to that particular domain. But to cap off the evolutionary story, I'm in a minority here. Most evolutionary stories about how human beings became what they are, how you, just another great ape, with the common mammalian brain and the common primate brain, can do all these spectacular things, begin with the idea that one of these abilities was all important. And you developed that, and it made it possible for you to do the others. So a very common one is tool use. Human beings use tools. They use tools to make tools. You developed the ability to make tools. This gave you the neurobiological computational power to do other things. And so suddenly you could have syntax. Or the manipulation of the hand and the opposable thumb. Wow, what a fascinating thing that calls for an awful lot of neurobiological anatomy. And once you got that, well, then you had the right kind of neurobiological patterns to be able to do other things. Or social cognition. Yes, we learned how to coordinate with others and Machiavellian intelligence. And once we had social cognition, well, then the other things just came along. Another one is, of course, language. Language was the big breakthrough. We were basically just like all those other apes, but we got language, and then, hey, all these other things became possible, social cognition and so on. No, the point that I am making, and I'm in a minority here, this is an assertion, this is controversial, is that no one of these abilities came first. No one of these abilities ran up to perfection and maturity and then made the others possible. On the contrary, it's not any one of these abilities, but something behind them. The ability to make integrating networks of a slightly higher kind than any other species could make. And once we had that advance in mental operation, then all of these other things become possible, partly because they can come up together. They can feed off each other and bootstrap each other. Remember, they're a Cub Scout pack. The cub makes the pack go, and the pack helps the Cub Scout grow. So we're starting with the mental operations, because that, I think, is where this story starts. And we will continue to advance into the structure, function, and development of language phylogenetically and ontogenetically. Thank you.